If you have been working for a long time in software development, you are definitely already able to work with REST services. And you have already seen that in these times we use the JSON format for our payloads when we exchange messages between the services and the clients. Long time ago we used to use SOAP services with the XML format, but these days we use JSON, and it's kind of a format that we use constantly, and we don't even think about it. But the original arguments for the use of JSON was that it was more compact and it was easier to transmit data using JSON. And XML was very verbose, had a lot of overhead, and of course we wanted something simple. gRPC, which is the protocol that we are going to have a look at today, adds an extra benefit in comparison to using JSON in our payloads. It is a binary format of sending payloads, and it has potentially the benefit of lowering the amount of data that we are sending and to make it easy to parse that data, since everything is sent in binary. But this video isn't per se about gRPC. It's more about how can we use Kong Konnect with our API gateways to perform a few operations that are related to gRPC, namely keep using JSON payloads to send data to our gRPC services, and to use something that is called gRPC protocol to send data from our web browsers to our services. But the video is also about gRPC, and so the video is split into two. The first part of the video is about gRPC, and it's about to give you a quick heads up about what gRPC actually is, and what are the benefits, and how can we implement it. And the second part of the video is the part that's actually about Kong and about how to use Connect and how to configure our gateway to use these functionalities in our application environment. But for now, let's jump into what this session is about. So the summary is, we are going to have a look at gRPC. We're going to find out what it is, what are the benefits, and what are the drawbacks. Of course, at this point, if you are already someone who has experience with working with the gRPC protocol, this first part may not be as interesting to you, so you can click on the link that's going to come up in the description to skip all of this first part to part 2, and then find out how to work with the Kong Konnect. But for this part, we are also going to have a look at how to create a gRPC service in Kotlin, how to create a gRPC client in Kotlin, and how to create a gRPC web client for the front end in JavaScript. These are 3 important steps. The examples are in Kotlin and JavaScript. However, it doesn't necessarily mean that these are the only languages that you can do this. You can also do this in Java, but we will see one example in Kotlin. The second part of the video is about using the gRPC gateway plugin. This is the plugin that will allow us to keep using JSON packages to send data to our gRPC services. And we are going to also use the gRPC web plugin to be able to translate data that we are sending via the gRPC web protocol to the gRPC protocol so that data can reach our services. And finally, we will draw conclusions about what have we done in this whole video. So let's start with one important note about me. My name is João Esperancinha. I've been in software development for about 10 years. Or a software engineer for about 10 years. I've been owner of the Just Protect channel for about 1 year, and I mostly do work related with Java, Kotlin, Groovy, and Scala. These are languages that talk with the Java virtual machine. and I'm also a Spring certified professional, a Java certified professional. I'm a Kong champion, and I make all of these technical videos to share knowledge that I have gained through the years, and also new knowledge that I am investigating and learning today. So let's now get started with gRPC. gRPC means General Remote Procedure Protocol, or Generic Remote Procedure Protocol, or Google Remote Procedure Call. The reason why we've got all of these different names is because this actually started at Google, and it was for a long time the known as gRPC, because G was added as the initial of Google. But in fact, it only means that we can, at least nowadays, it only means that we can use the gRPC protocol with different frameworks and with different platforms. And so we can say that Generic Remote Procedure Call is a modern open source network protocol that allows invocations of functions or procedures in the remote machine as if they were executed locally. This is an interesting definition, because if we use JSON clients, we are kind of doing the same thing. It's just that this is the definition for the gRPC protocol. And it goes on to say the result of the function is returned as if the call was made locally. This is what RPC means. General, in this context, turns RPC, as remote procedure call, into gRPC, and it means that gRPC can be generically used in different frameworks and platforms. So how is this made generic? Well, gRPC protocol relies at the beginning on protobuffer files. These protobuffer files are easy to outline files that can be used and are used to create the backbone of our services. So essentially the skeleton of our code. They are language agnostic, they are platform neutral, they allow for binary serialization, and they have their own language. And what this also means is that we can translate this to other different languages. And we will see that in our project, we will generate code in Kotlin and Java. And although we are only using code in Kotlin, these are the code bases that are going to be generated for us to use. It's a sort of library that we generate on demand with these protobuffer files. So let's now start with the backend service, a bit of theory, and then we'll skip on to the demo, or move on to the demo. gRPC backend services start out as protobuf files. The word protobuf means protocol buffer, and it essentially means what it actually does. This is the data structure format used in the buffers created to transmit the data. So how do we generate this? In our project, we're going to see two ways of generating this. One is manually, and the other one is using Gradle. Gradle will facilitate our work to build a project, but I will give an example of how to do it manually also, so that we can understand everything that's going on in the background to be able to generate the code base that we are going to use as a library to create our services and our client. And here we have an example of a protobuf file. It is important that we understand how this works so that we also have an idea on how everything plays out in the end in our program. A protobuf file is very simple, but it's also very dynamic, and it's also a tool that we can use to create different kind of services, not just RPC services. But let's see. In the first line, we can find the definition of the syntax. This is how we tell the compiler what kind of syntax is in our code, so that it can correctly interpret what we are writing here. It is also important for our IDE. It will allow it to give us warnings or errors, or tell us where errors have been made in the definition of this file. We can then define the package of where we want the generated code to be, and this is basically one one-liner that tells us the package and the name of the package. Then we need to define the protocol that we are going to use. In this case, we use RPC before the method name. Here we have a capitalized send, but that is just the method name and just the way we define it in a protobuf file. We also define the input parameter. This is message, that's the type. And then we also define the return value and its type, which is message response. In the protobuf file, we don't define very complicated things, at least not for this example, and we keep everything very basic. And if you look at the definitions of message and message response, these two types are kind of defined in a different way that we are used to in normal code like Java or Kotlin. Essentially, we define, for example, in the input type, that is message, we define it to have two fields, text and author. We tell that these fields are of type string, but then we assign 1 and 2. This 1 and 2 is not an index, it's not an ordinal to define the order of the constructor. It's also not the value, of course, because 1 is not a string. And it's also not a way that protobuf has to interpret a string. What it is a field value that is used when these messages are being encoded while sending the data from the client to the service and vice versa. This is just the actual number that will allow the gRPC protocol to know which field has which value. And we are free to assign it whatever integer we want to assign it to. And that's why we have text with 1, author with 2, and then in the message response, that's why we have the result as 1. The result is just an indication if the message has been successfully delivered or not. And this completes the definition. When we run the code generation on it, either via Gradle or manually, as we will see, we generate something like this. Not just this, but a whole lot of more code, but we are only going to use this one for our services, and these are the bits of code that I find important to talk about right now. So let's see, we have an abstract class, messenger coroutine impl base, with two important methods, send and bind service. Send is what we want to implement for our service, and bind service is something interesting to have a look at because this is what allows us the service to start via an executable jar file. The send method needs to be implemented because this is exactly what our service is going to do. And in our abstract class, we already have a warning that the method is unimplemented. Well, that's because we need to extend this class, create a subclass out of it, and implement the send method. And this is one example. This is the messenger service that is going to implement the messenger coroutine impl base and therefore override the send method. This is of course generated by Proto here, and we can see that we are in our send method. We are returning a message response, we are printing the request to the console, and we are saying that the result is 0. So the idea is a bit to mimic what you get in the shell. When the result is 0, you know that it's successful. So let's continue. The message service, to create the message service, we also need to have this concept of server. So we have a server that wraps around our message service that starts and then serves our service. And then we are allowed to use these methods. The way it works, we define the port with this server builder. We add an instance of our messenger service, and then we just call the method start. So this message service is started right over here. we start the service, and then we just create a shutdown hook. This is not mandatory, but this is kind of one way. This is one way of letting our service run and simply allowing it to be open to receive requests. We also have in the generated code a client. So just as the gRPC services, the client files get also generated with the protobuf plugin. Once that is created, we can easily use the client to access the service. Notice one important thing. I'm always talking about the gRPC plugin. This is something generic that we can use outside of Gradle, and we can also use in Gradle, and we can also use in Maven. I'm not showing the Maven example in this video, but what's important to be aware of is that there is a protobuf plugin that we have to use in whatever form it takes. This is the plugin that we need to use all the time. Okay, so this is the code that we need to use for the client. And for the client, we've got one interesting class that is the messenger coroutine stub. This is automatically generated for us. It has a builder and it has a send. This send request we can use in the client, and we will use the messenger coroutine stub with a channel in it. The thing is that the messenger coroutine stub is actually a functional class that will allow us to send requests to our service. And so the way we use this is first we create a stub with a channel. I will explain later what a channel is. And it will allow us to send a message that we create with this message function. And then, of course, we print the results to the console. So essentially, when we send a message, we send a message with arguments text and author, both of them strings. We create then a message to be sent, and then we send the message using the send for the client. Stub here is more in the context of it's a stub to be able to access our service, but it's not technically, it's not a mock client. It actually is a real client in this case. So now we've come to the point where we will start our demo. The demo is divided in two parts. One is gRPC without Gradle, and the other one is gRPC with Gradle. But let's first look at the most complicated bit. This is important so that we, again, to have the idea of all the moving parts that are working in the background for us. This one, in the end, is very, very easy to use. It's very, very easy to implement, but it's important that we understand everything that's going in the background. So let's move on to that. This is the project Wildlife Safety Monitor. This is a project that I have created to support another video that I have uploaded about Kuma meshes. If you haven't seen that video, I recommend that you do that, at least to understand the context of this whole architecture that is implemented in this project. The video is this one. The link to the video is also here, and you can also find the link to GitHub right over here or in the description. I can show you here where I have this project. This is located on github.com. You can use my handler, j.esperancinha and then / wildlife safety monitor. And here you will find all of the different modules that are relevant for this video. They are all of the messenger modules. So here we can find the messenger client, the messenger frontend, the messenger pre-service, the messenger protos, and the messenger service. These are 5 modules that are examples of how to use gRPC in these kind of architectures. So let's now go back to IntelliJ, and here we can find this project. And the first module that we want to have a look at first is the pre-service module. This probably is the most complicated module of this whole video, because here we are diving into the basics of gRPC, and here we are doing everything manually. So that means we are going to have to install two important things first. One is the protobuf application, and the next is the plugin itself. The plugin is a jar that we literally just download from the web and use it with the protobuf command. That is also a proto-C compiler command. But let's have a look first at the scripts. We can install the protobuf application using brew, or we can also install it using apt. In the script here I have brew. I have installed brew for Linux, but this doesn't have to be the only way to install. It is also available for apt, but it's only under another name. And the other name is, if you go to their website, is protobuf compiler. Essentially, this is what we are doing. We are installing a protobuf compiler application. And then we need to install the plugin. To install the plugin, I have created a script for that. Let's have a look at it. The script contains first a curl call to the Elasticsearch engine of Maven, which is implemented with Solr Search. And here we get a JSON with the package of the Protogen gRPC Kotlin plugin. And that we can then use as a variable and then do the curl to get the latest version of this plugin. And then the last step of this script is to create another script which will be used in combination with the proto buffer compiler. It's not the usual thing that we do, but it is how this is done in this case. So that's why this module is a bit more complicated. But let's have a look now at the plugin template that I am using to create this. So this plugin template is actually very much simplified. And I'm making here the assumption that we are using the folder that where we are. I'm using the same folder where we are executing the command, as the same as the folder of where the plugin is installed. So this template, the only thing that it has that it's different from the actual file that we are going to use is the placeholder for some version. I called it some version, and then here, if I use the if I open this file, then we can see that it does a replace of that some version with the version that we need to install, and therefore it generates this other plugin, this other file that essentially contains Java jar with the actual jar that we want to use, and then this one is the parameter of the actual protobuf file. But this works in combination with the actual command of proto-C. So using proto-C, we can define with --plugin the actual proto-C gen gRPC KT to be the bash file that we just created with the download latest Kotlin plugin script. Then we define as the output folder the generated code folder, and then finally we define the protopath, thus the place where our proto file is located, in two ways. The first argument is the directory of the proto file, and then the name of the proto file. And this is also why we've got this if here at the back, and that is just to make sure that every time we run this script that the generated code directory is regenerated, because the script doesn't really work very well with an existing generated code folder. So the output folder is generated code, the directory of the proto file is dot, so the current one, and the proto file is additioner.proto. We'll get to what the additioner.proto file does, but for now, or what is meant to do, because it still won't do anything once the code is generated. So at this point, we have seen all of the stuff that we need to get the code generated, but we have not looked into the proto file itself. So the proto file example in this case, is just an additioner. The idea is to create some sort of small calculator that only does addition operations, and it will use, we will have a method that will receive two fields within a type. So the additioner request will have two fields, num1 and num2, and with those two fields it will calculate the result. To define it, of course, we need to define the syntax, that's proto3, then we need a package, which is this package right over here, and then we name our service. We know that we want an RPC method. We want to call it add. The type that it receives as a parameter is additioner request, and the return is the additioner response. So the next step is logically to just generate the source files of our protobuf service. Let's do that. So we know that the script is proto.c.gen, and when we run it, we see that, well, the first good thing is that we don't get any errors, and the second good thing is that if we look at our module folder, we'll see that there's a generated code folder that has created a class within the package org.j.messenger, and here we can find the generated file for our service and our client. So here we have the service description, we have the add methods, we can find the build, we can find essentially a lot of the things that we have seen already in the slides. But as I've mentioned in the slides, this is only the skeletal implementation of the additioner service based on Kotlin coroutines. So essentially we've got all the backbone now generated for us to create these services. But here's the catch now. I did this all manually for you to understand that there is namely a plugin that we have to use to make the code generation, and there are ways to generate this code. An engine, let's call it that way, that triggers this generation, which is the protobuf compiler. Gradle combines these two in one single configuration and one single plugin, which is called the protobuf plugin, which we can configure in the build.gradle.kts file. So now we're not going to have a look at how it works. That is now for the next part, which is the generation of the service using Gradle. And for that, the first module that we want to look at is the protos module. So the idea is to create a separate module that contains all the proto files that we are going to use. This provides more code clarity and provides more understanding of what we are doing. So essentially it's just a module. It doesn't have anything else but a proto file. It might have more proto files if we are doing a more complex service or a more differentiated kind of service package. And we can find here the exact file that we saw in the slides. We can also find the build Gradle file, which essentially is pretty much an empty file with some sort of with some very basic installation for Kotlin, which is also not necessary. As long as this is a Gradle bundle, then we know that we can import the proto file to our projects, and that's exactly what I'm doing in the Messenger service module. So here in the build Gradle, I am creating this project, and the first thing that I'm doing is adding the plugin protobuf. Now these projects are all created using TOML, so to illustrate which plugin exactly I am using, we need to go and check out the TOML file, which is located right over here. And then here we can find that we have a bunch of things related to protobuf, We got the protobuf plugin right over here, com.google.protobuf, gRPC, and the version is 1.15 in this case. The version is 0.94. And in the libraries, we are using a lot of these gRPC libraries that are necessary in order to run our service. An interesting thing here is that the gRPC is using netty at the background. This is not, I don't think this is something necessary, but this is how this example is being made, using netty. Maybe it's possible to do it also with other kinds of services, but for this case, we use netty. So let's go back to the service. So we are using the protobuf plugin, and we are also defining the dependency for protobuf over here. So we are saying that protobuf is going to use the protobuf, the messenger protos project, to include in the protobuf code generation. And probably the strangest part here, and this is one of those things that you install once and it works forever, it's this protobuf task definition. So what we have here is different installation configurations, and we are creating tasks for gRPC, tasks for gRPC KT, and a task for Kotlin. All of these three will work together to generate Java code, Kotlin code, and allow us and create code that is open to be implemented by our service and by our client. This example is located in their website, and that is with, I think it's this one over here. Yes, so this is the where we can start doing an example. So all of these examples are made following the examples located on this website, on the grpc.io website. And we can also find this example in GitHub, of course. This is the gRPC Kotlin project for Kotlin, but there are other projects. And we can also find an example of it over here in the quick start page. No, apologize. I think it's this one. Yes. So in here in the gRPC Kotlin CodeGen plugin for protobuf compiler, this page over here, then we can find the configurations that we need for our project. In this case, for the protobuf plugin, all of these configurations need to be in one way or the other adjusted to your project. I adjusted these to mine, so the difference isn't too much. The only thing is that I have used the TOML to define the versions that I need to use in this project. But for the rest is exactly the same. Now, once this is done, what the gRPC plugin will do is generate source code, of course, and this is what we see over here in, not in Protos, but here. Generated sources. So what we can see here is a structure of different code: gRPC, gRPC KT, Java, and Kotlin. These are a bunch of classes that we may need to implement our services. So now we have our classes implemented, and then the only question that remains is how then we change this now to make our services usable and our clients usable. So the thing is, we can go here to Messenger Server, and this is an example of that I have done based on what is already available on that GitHub page. essentially it all boils down to creating a server that wraps around the service that we create manually and defining a port for it to open and to receive requests. It's very simple, just like over here. As I mentioned in the slides, we start listening on a port and we start using a service that we define here by implementing this messenger coroutine impl base. And of course implementing the send method, which is the method that we are using in this case for this example. What this simple send request does is printing out the actual payload on the input and just returning 0 at this point. There's nothing different here, and the idea is that we understand that we have received a good request on the input. So this should work, and I might as well just start the service right now. So messenger service, this is this Kotlin script file, and I run it. We need to wait a bit. Okay, so now this service is running on port 50051. The port is defined here, so if there is no port environment variable, then we just say that it's 551. So we've got now the service running. How about the client? Well, the client is just as simple as the example before. However, the client has some small differences. We do make the code generation in the same way. Sorry, wrong REST client project. Let me go to the messenger client project. So this is our messenger client, and remember that I've told you before in the slides that we were going to have a look at what the channel actually means. Let's have a look at that just now. So the rest I've explained already in the slides. We have a messenger client that is a closable. It is a closable object. It receives as an input a channel, and it creates a coroutine stub to send requests to our service, which is done right over here with the send request. But what is then this channel? Well, the channel is just something that the client builds to access our service. This is where the buffers are created so that we can send the binary data via the buffers to the service so that the service can interpret them and then make whatever operation we need it to do. So by default, and I've got this commented out just for tests, just for quick tests, the client is going to access port 50051. It's going to create a channel for localhost and the port that we have defined, this 551, and then it's going to send a message. And the message is just this huge text, and as an author, me, João. Let's do that. So now the server is running, and if we send this request right now, we will see that we have gotten a received 0. And we have seen before that the code gets generated with this stub name. Stub is subject to interpretation, but this is not a mock stub. Again, this is a real call, and we can see that when we open this, we see that our server has received the whole text and me as an author. And so we have now established a communication between the client and the service. And so we can now see the gRPC services in action with gRPC clients. However, this is just direct communication, client service, service client. And these things in the backend work really, really well. But we want to talk to our service. in two ways also. At least we may want to talk with our service in two ways, two extra ways. If we have a service that is running with gRPC, odds are that we may want to also be able to provide our service and our functions to other people that have or other customers that are using these services, but they want to use these services, but they want to use it with JSON. They don't want to use it specifically with gRPC. And therefore, there is a plugin, which is the gRPC gateway, that allows to do just that. People can send JSON requests, and they can reach the service seamlessly without even knowing that it is a gRPC service at the background. It's just that the API gateway is in the middle to get that request there. The other thing is, we may want to directly communicate with the service, of course via a proxy, using a web browser. The thing is, for web browsers, gRPC is also available, but it is called gRPC Web. So in order to communicate from the front end, from a client, someone that is sitting at a computer and wants to edit things in a web page where the services are gRPC, that person will not be able to do that directly. There has to be some kind of translation mechanism in between. And that is what the gRPC Web plugin does in Kong. And we are going to see these things working together. We have now seen how to make a gRPC service and its matching gRPC client. And this is all done in the backend with backend code. Now let's look at the example of the front end, which implements gRPC Web protocol. And for this, we need to also generate code, and we also have a set of commands that we need to install before we proceed to that code generation. And to do that, I will now let you see the script file that I've created for this, where everything is nicely organized and again prepared for Linux. So there might be some variations if you are using Windows or if you are using Mac OS. So let's get into it. In the make file, we will find that we will need to install a couple of things. If you want, optionally, you can install Yarn or NPX. But the most important thing, actually, you do need to install NPX, sorry, because you do need to make a build with Webpack. Or if you have other alternatives to build this with Webpack, then be my guest to use them. And then other things that we also need to install is the protobuf. We have seen that before. If you have followed this video up until this point, you already have the proto-C compiler installed. But we also need the proto-C gen gRPC Web, because we are going to generate gRPC Web code. And then we need to install this proto-C gen JS. Once we have these two installed, then proto-C already has the libraries and the modules necessary to proceed with code generation. To do that, we will use proto-C, just like we did before, -i, and then that is the location of our proto file. Then we define the style of our code, and that is CommonJS for both the JS code that comes out and the gRPC code that comes out. And finally, the mode is gRPC Web Text. Now, these are generic configurations. We can, of course, refine and fine-grain these configurations for our purposes, but for the purpose of this example, that, of course, is related to how do we then later on configure this with Kong, this is enough to know at this point. The code generation is important because now we will then get the gRPC code, and then we will need to apply a proxy to it. But before we get to the proxy, let's first now generate the code that we need. And for that, we can just say make generate code. I can now do the generate code because I've already installed these libraries. So make sure to have them before you run this command. So now I've generated the code. I don't see any error messages at this point. And if I look at the module folder, I now see two different files, the messenger gRPC web pb.js and the messenger pb.js. These are important files. The first one is related to the gRPC services, in this case with our gRPC client, and the messenger pb is related to the payloads and how our services work. So that means that we now have the two library files that we need to create our own code. And to create our own code, all we need to do first is to install the libraries that we need. And those libraries are, and for this we can just look into the package. The libraries are this. So in the dev dependencies, we need to use the gRPC JS, the proto loader. The async library is important because we are using asynchronous processes, and the Google protobuf library, the gRPC web, Lodash, Webpack, and Webpack client. These are all libraries that are important for the not just for gRPC, but also for the different things that we are using in our client. If we go to our client.js file, which is where our code lives, we can see that we first do a required, and we see already that the IntelliJ says that it doesn't resolve this function. This is because I didn't run yarn yet. So if I run yarn or npm install, then we get the node modules, and IntelliJ then finally can recognize our code. Now I'm saying here in the first part of the code that I require the type message, and in the second one I require the type messenger client. The client is important because this is how we communicate with our backend, and this is how we define our client, similar to how we've done in the backend. It's kind of like a channel. So we define the URL where we want to make the requests to, and we can optionally add credentials and options to our request. But for this simple example, that's not what we need. Then we define our message, and we essentially set the text and the author, pretty much in the same way that we did with our backend client. And then we send the request where there's going to be an alert, where we are going to see that the request payload has an array of values, and the response payload also has an array of values in the response. And from the response we can get the result, which is how the code is generated. So we don't get the body, the JSON body with this JavaScript code, but we do get the different elements of that array via accessors. And then for the second bit, I do something different, because in the meantime I have already updated the backend service to introduce an extra functionality, and that is a blocked user. If I send this user, which is named blocked, the user will be blocked in a way, but it's just for us to see that we get a different response. And the response in this user is 1. I can show you that in the messenger service. So here in the service, I have implemented the send method to return a result with 1 if the author is blocked, and result 0 if the author is anything else. So now what we now have is our generated JavaScript code. We have the client implemented, but now we need to visualize this in a certain way. And that is, of course, with an HTML file. So here, the only thing that we do is we import that script that will be generated in dist/main.js. And it only means that when we refresh this page, it will run that code, and we will see then the results of our query. But before we do that, let me just remove all my running images at this point. But before we start the server, we need, of course, to compile the code. And for that, as we have seen before, there is a build script right over here, and that is build npm, or just b, or just make in this case, because it's the first script in the make file. Now we have everything compiled, and if we now run this in our browser, so if we go here to just directly, without any simple service or anything like that, so just if we use the server provider by IntelliJ, we see that this happens. But as we can see, we get an alert notification, but the alert notification, it's just the first alert of our sending message. So the payload that gets sent contains an array that is hello there and my name, João. However, we don't get past that. That's because the response fails. So it says it cannot read properties of no, reading get result. The result isn't available for us in the payload, but that is because we don't have a response payload. There has been an error. And if we look at the backend code of the backend logs of the service, we will see that we find very vague messages, unexpected HTTP request options. So our service is trying to tell us is that it doesn't understand this request, although it kind of is similar to what it expects, but it cannot read it. That's because we cannot communicate directly from the backend, from the front end to the backend, without having anything in between to translate those requests to gRPC. And for that, to translate those requests, we need to use something called an envoy proxy. If you have seen this video of Kuma meshes, or you know Kuma meshes, or you have ever worked with envoy, you're already familiar with this, with what envoy proxies are, what envoy sidecars are. These envoy sidecars are important. In Kuma meshes, for example, they are they work underwater. We don't really see them, but we configure them so that we can configure the data flowing through our meshes. But they can also be configured manually, and this is what we are going to do in this case. And the only thing that this envoy sidecar is going to do is it is going to translate our data from gRPC web to gRPC. And to do that, we need an envoy script. This has been taken from their website. I think I have here the link, if I'm not mistaken. Yes, so if we go over here to this website, there is an example here about how to make a gRPC web hello world. I have taken my example from this, from this envoy YAML over here. Actually, it's pretty much the same as this envoy YAML, if we can also have a look at. So it has a lot of configurations, but important is here that we make the socket open in this line over here, the socket address for our static resources, and then we redirect those requests to this port 1990. And a lot of things happen right over here with these different HTTP filters, and these filters are responsible to translate our data in between the different requests and responses to and from the server. So in our own project, we can find exactly that. I will make the request to port 8080, and then I will redirect those requests to port 551. So let's try and do just that. To run this envoy sidecar, we need to call a Docker command. So this sidecar will run in Docker via the image of the envoy sidecars. And to do that, we just need to run this Docker command with these different parameters. So essentially, we are running the envoy. We are running a container from the envoy image, and we are saying that our envoy configuration is this one. So let's run this proxy, and to do that, we can go here to the command line. I prefer to do it to do this in the command line because if you run it via IntelliJ, you may run into a different shell, and sometimes it doesn't work really well. So I do it like this. So it says it does not find the image locally. It will now download the image to be able to produce this container so that we can run our requests and so that I can run this example. And in the meantime, it's already completed. Okay, good. So now all we have to do is to make the build. because I've already changed the port to 8080, I can now make the build. And as I make the build, now the code is ready to communicate with port 8080. The envoy script is already running, and the server is running as well. And we can see that the last error message is already gotten messages, but this is probably because the page has refreshed. So if I close this one, I have now 1, 2, 3 messages, and now I should, if I refresh this, yeah, indeed, it was already sending messages. So if I refresh it now, just for the sake of demonstrating this, I send a request with my own name. This is accepted, so I get no error messages or error code in this case. When I send the blocked user, I get 1. So here we can see that it's making the requests to the server, and if we go here to the back, we can see that the backend is logging hello there with my name and hello there with blocked. So these are 2 different requests with 2 different responses. The role that you will see later in the video, the role that Kong Konnect will play here is to allow this configuration that you have now seen with the envoy sidecar to be implemented in the API gateway with a very simple configuration, which will save us the work to make all of this for especially the envoy configuration. Every time we need to run a proxy with this protocol switch. But for now, let's have a look at some of important aspects of the Kong gateway in this regard. So we go back to our slides. And the first thing that we need to understand is, how do we test this? So when we use Kong Konnect for testing, we need to create a data plane node. And when we do that, we usually get a huge script to start out a data plane node and then make operations with it. The data plane node, if we just run the data plane node like that locally, it will not have any understanding of our local network because it's working isolated, and it only has an understanding of external services. So everything around the web, for example, the pet shop service that is openly available that anyone can use and is fairly used in in many different examples, but we don't have it locally, and I want to deploy this service locally. So one way to do that is to include that script in one way or the other within Docker Compose. And when I looked at that script, the one thing that I saw is that we get a bunch of variables, and that's it. We send those variables to the Kong container, and that Kong container will work with those variables and make whatever we want, including the connection to Kong Konnect. So that's what I did. I made a script to include those variables in our configuration using another script that will translate the whole command into environment variables and make it available for the Kong container start. And the best thing to explain this is to show it exactly in the code. So let's go back to IntelliJ, and here we are going to find, especially in the service, we are going to find in the service a Docker Compose file. But before we get to there, let's see what's in the Docker Compose file. It is a very simple Docker file, which starts out with the image of the Java JDK 21, and then it will inject there the messenger service and then call an entry point. This is one of the most simplest ways of starting a service using Docker, using a Docker file, using Docker, and then we just start the service like this. This will start the messenger service, and it will be open, of course, in port 551. this is the Docker Compose file. And the Docker Compose file contains first the definition of the first service, that is the WLSM messenger service with the same host name. Context is dot, of course, is the service, and then we have the ports. So this will start out the WLSM messenger service, but it will also start Kong in what it looks like to be a very simple way. So we are just using the env file and using .env, but this .env has a lot more than what we may initially think. It has all of this. And these are all the variables that come into our machine when we start the container using the script that is given to us in the Kong Konnect website, and that is this one. This Docker run, if it is familiar to you, and if not, I will show you in a minute what this is about. So we get all of this run file with all of these variables, including the certificates to connect our machine to Kong Konnect, and the ports, and all of this stuff that I wouldn't be able to explain in details every single one of these variables, but I know that they are needed to start a container, and that's what's important. Then we get this container running in the same running in the same network as the WLSM messenger service. The two containers will start running together once we start this file. At this point, all of these certificates have expired, so I need to generate new ones to be able to connect locally to Kong Konnect. And this is the next step what we are going to do. But first, let me show you what we are trying to do. Again, let's go through the topics and recap everything we're going to do. Kong Konnect goals. We want to make a direct connection via gRPC. We want to connect to gRPC service via JSON requests. We want to connect to the gRPC service via web requests, all requests made from a browser. So we've got three types of connections that we want to make. The first connection is this one. It's a direct connection from our user up to the Kong gateway and down to the gRPC messenger service. The admin, which is us in this case also, is going to connect to the Kong Konnect and configure this for us. The second example is an addition, which is the gRPC gateway plugin. This plugin will allow us to make JSON requests from the user perspective. It means that we will be able to curl requests to our gateway and get these requests through to the messenger service. And in the last example, we are going to use with another path the gRPC web plugin, which is this one over here. And that means that we will have three different paths. The first one is API/v1, typically used for REST services using JSON. Then we have /web, specifically for requests coming from the requests with the gRPC web protocol. And then finally, a direct request from the Kong gateway to the gRPC service, which is actually the first one that we are going to implement anyways. Okay, so let's start and let's configure Kong to work with these services. So now let's have a look at the example of Kong. Finally, we are going to go through Kong Konnect and the steps necessary to make the features available that we have discussed in the previous sections of this video. So for the first thing that we need to do is we need to go to the Kong Konnect website, and here we are going to create our own account. And we can just select login, for example, and it will, if you have already logged into the Kong Konnect web application, you already have some of your data is already there, and you will only have to log in and just create a new Kong Konnect organization. If not, then the best is just to come here, and you can then continue with Google or GitHub or with a Microsoft account or with SSO, or you can just do a sign up here, and then you can say you want to sign up with GitHub, Google, or Microsoft. It doesn't really matter. The registration is very straightforward. For me, since I am a Kong champion, of course, I can just log in and kickstart the whole process. So here we need to give a name to our organization. I'm just going to call it test and then my name, like this, test J Esperancinha, and just create the organization. The next step is just a series of questions. So for example, select the region to continue to your Kong Konnect platform. Let's use Europe, and it should take a while, and we will have a set of 4 questions that we need to answer. It doesn't really matter, but just be honest here. It is important that we let Kong know exactly what are we using this for, because we are entering a trial period, and of course, if we are entering a trial period, it is important also for Kong to understand what are your interests here. Why do you want to use these plugins? Why do you want to start Kong Konnect anyway? So we're going to say, for me, I'm a software engineer. What is my level of experience? I could say intermediate or expert. I'm going to say intermediate. Do your organization use any API management technology or solutions? Let's say open source, for example. What is the reason for signing to Connect? I'm going to put here education or personal development. And then finally, the company size, like this, for example. There we go. Now we have the whole Kong Konnect section open for us. And the first thing that we need to do is to get to the default node, and that is this one over here. This is the default gateway manager, and we can create here a new data plane node. So let's do that. A data plane node is essentially an API gateway that will run locally in our machine. We can generate a certificate. I have a Linux machine, so it's probably better just to use a Linux like this, or like this. Generate the certificate, and this is a Docker run command. I have created a script that I want to show you in our code base, and that script is located right over here in the entry point. Now it is located in WLSM messenger service, and inside of it there is a generate Docker compose. What this script does in general words is it uses a lot of regex patterns and tricks to get the variables from the Docker compose and then use them to generate the .env file, which is this one right over here, which already has some data of a previous data plane node that I was using. This one is not valid anymore. So what we do here is we go to this script.sh. It is a file that is not versioned and is a file that you need to create locally. So just script.sh. And here you just copy the contents that you just extracted from the website in your Kong Konnect account. When you do this, the next thing that you need to do is to run this generate Docker compose. I have created a makefile script that will run this automatically, and we can use that one right over here, or perhaps maybe not. Yes, because it is a Python script. So what I can do here is just add a script, generate env file, and just go over here and just say Python, and on this one, generate Docker Compose Pi. If we go here and just generate Docker Compose, make generate M file, then it will create a new M file, which is this one, and this one has the new variables of the new configuration file. Now, what is important for us to understand here is that, as I mentioned before, this will create two containers in a single Docker environment, a single isolated Docker environment, and one of them is the WLSM messenger service and the other one is Kong. Let's first have a look at how the WLSM messenger service starts. For that, we have this Docker file, and this service will start from an image, and that is an image with in this case the JDK 21, and it will create a container from that, and it will add the WLSM messenger service jar file, and it will then call the entry point, which is this bash script. This is nothing too special about it. It's just a jar that starts and it keeps running in the background. For Docker, for Kong is a bit different because the definition of the Kong image is a bit different than the one we are used to, which normally is very complicated. This one is also very complicated. The only thing is that we don't see that in the Docker Compose file, of course, because everything that is complicated about this Docker container is listed in the M file. And if we go to the M file, of course, we see the new configuration of the new data plane node. Important here to also understand is that I've just showed you the credentials, or let's say the certificates, to be able to access Kong Konnect via the data plane node. Make sure to delete this information at the end. I will there is a section of this video almost to the end of it where I will show you how to delete the information that you don't need anymore. So if you're not using these data plane nodes, is also very important for security purposes to delete the certificates from the gateway manager. But I will show you that later. For now, we have two containers: the WLSM messenger service and the Kong service, which is our API gateway that will now connect to our Kong gateway, to Kong Konnect. So let's do that. The first thing that we also need to do is Docker Compose down. In my case, just because I have used these containers before with a different set of certificates, then I use Docker Compose build, and this will rebuild all of our containers. And then I will do Docker Compose up -d. So they have all started. Now hopefully we will see this in our gateway. It's now waiting for the new data plane node to connect. And it should be there in a minute. We can just see the logs also. Perhaps that's also a good idea. Yes, so the data plane node has already connected to our Connect environment. So we can come here and then select the data plane nodes, and then we see that it is connected. Now what Kong Konnect is doing is checking if the data plane node is compatible. And that has just happened, so the compatibility is done. We are ready to start creating a service. As we saw in our slides, the first thing to do, well, actually I presented it as the last point, but the first thing to do is to make a gRPC connection via our client through the API gateway. So this is our data plane node running. It is now running in our machine locally. This is our API gateway, and it is connected to Kong Konnect. What we now want to do is to configure a route that is going to take our requests to the gateway through to reach its destination on the gRPC service. And to do that, we first need to create a gateway service. And the gateway service can be added this way. And we can call it a gRPC service. And we don't need to tag it. If you want, you can tag it, but the idea is just to create now an upstream URL with it, and this is just going to be this one actually. So we are going to connect to the WLSM messenger service on port 551. This is the domain name, so the host name of our machine inside our Docker Compose. So from the outside it is still localhost, but here is WLSM messenger service on this port. And another thing that we also need to be conscious about is that this is gRPC. So we are not connecting via HTTP, we are connecting via gRPC. So if we save this, it should work, and it should automatically configure our service to use gRPC protocol. Let's check if that is the case. So if we edit it, we see that the protocol has been selected to be gRPC, and that the host is WLSM messenger service, and that the port is 551. So this seems to be correct. It's exactly what we want, but we still need a route. And for that, we can just add a route from the gateway service. We have different configurations. Here we have the route. And here we can just add a new route from the root and from gRPC. And we protocol gRPC. I know that I have mentioned in the slides that I wanted to create everything at the same time. However, I realized that to do that, I would have to introduce extra steps that are probably not in our interest for this introduction to gRPC configuration with the plugins in Kong Konnect. And so we're going to do them separately. So now we are only going to create the normal route so that our API gateway can forward the requests or relay these requests to the gRPC service. So let's do that, let's save it. And now what should happen is that when we run the client against this, against the gateway port, which is 8000, it should be, that request should be relayed to the gRPC service, and then we should just get a 0 error as a response from the service, as we have seen before with the direct calls in our local machine. So let's just do that. Now that I have here my client, and the client is now hard-coded to connect to port 8000. So let's do that. Let's start the service. And as we have seen before, this is just going to send a bunch of text with my name on it to the service. And what we should expect now is a 0 as a response. Let's see if that's what happens. So now we are able to make our connection via this port to our API gateway, which then relays those requests to the backend service. What we now want to do is see if we can make requests via JSON, which would be another interesting thing. And to do that, we can actually use the API v1 path that I've mentioned before, because there, if we make REST calls, we can actually control really well the path of the request we want to send. And for that, we just need to create a new route. And this new route is going to be, well, we don't need to give it a name. But maybe it's handy to give it a name in this case, because this will be the API route. And the service is this one. And the reason why we are adding this route right now is because what we want to do is apply the plugin to this route. So, but the first step is to make this path available to our service. And now what we want to do is to add a plugin to this route and then we add a new plugin, and the plugin is very simple. It's just simply called gRPC gateway. So we select this one and we save it. The plugin is now enabled, and what this means is that the request that we send now to this route should be forwarded. So that means we're going to make a post request, and this post request will be relayed as a gRPC request to the gRPC service. Let's try and see if this one works. Requires a proto-file. Yes, this is true. So if we go here to plugins, so the plugin actually needs a proto-file, which we can configure right over here. The reason for this is that the service needs to know how the endpoint in the gRPC service is configured, and for that we actually need to add a specific proto file that I've also added to the root of this project, and that is this one, and this is specific for Kong. The important thing here is that we need to define how our messages are going to be built, of course, because we can add a plugin, but the plugin has no idea how this payload is going to be generated. And so one way to do that, actually the way to do that, is to define our services a bit with a bit of an extension, and that is adding this option and saying that what we want to do is to use the Google API HTTP, say that our post is going to be made to v1/message, and the body will be a body matching the message. And what we do is put on the name of this file right over here, save it, and now Kong will not be able to find this file. So we need to put it there available for it. And to do that, what we need to do is to come over here to our makefile, and here somewhere we have we've got the a copy Kong proto script that will do that for us. But the thing is, this script doesn't really work if we call it from the makefile. So the best thing to, because the Kong container ID is not available here, so what we do is we go to the command line, we export this with the correct ID of Kong. So if we go here to Docker PS, so this is the container of the Kong container, and then we add it over here. Now we have the container ready, and what we do, we go to the proto project, and here we copy the Kong file to 2 locations. Actually, when I did this, I actually had the environment variables already created. So what we do is something like this, and then say like this. I think this is how it works. Yeah, okay. If we now call make copy, go to service, make copy, we go to messenger service, and we perform a make copy Kong proto. It copies all of these files into the containers, and now hopefully we can make the request correctly. So let's just run the post request again, and now it says failed to transcode file make. Unknown path API message. Yes, so the let's do this one from the command line, see if that works. No, it doesn't work. Oh yeah, because the slash doesn't work. Failed to transcode proto file unknown path API v1 message. That is probably because our message conf transcode profile unknown path API v1 message routes. API v1 message. Okay. Should have worked. All right. Okay, so there was a problem with the path. I had to fix that very quickly. So essentially, this post path must match of course the path that we are defining in the API gateway, and that's why this plugin now works, because this path is an absolute match with what we defined in this Google API HTTP option that we have set for our send method. Okay, so now we have seen how the gRPC gateway plugin works. We have seen how to relay gRPC service gRPC requests with the gateway plugin and directly. Now it's time to see another curious case, which is the front end for browsers, which is using the gRPC web protocol and using the plugin that allows us to make that communication. In the meantime, I have removed the service and the routes that we needed for the gRPC gateway plugin. Now we are going to do that all over again for the gRPC web plugin. And for that, let's start with the configuration of the service. As we have seen before, we can make a gRPC service using an upstream URL that is the gRPC //WLSM messenger service :551. And this is basically just the location of our service and what we want to serve for our API gateway. Then we need to define a route, and now we have the route available, and we also have the service available. But we don't have the translation mechanism yet implemented, and this is where the plugin starts working just like the sidecar we have seen in the example in the first part of this video. And to apply this plugin, the best thing to do for this example specifically is to apply that plugin, of course, to the route. And the route is right over here, and we can just say, let's add a new plugin. And now we are looking for the gRPC web plugin, which is right over here. And then we make an export. Then we assign Kong container ID to our variable. And now we can run the copy. Now the file is in our Kong gateway locally now. And the only thing that we are missing, if you have noticed, is that we need to give this file name to our Kong gateway. So to our Kong gateway, to the web plugin. And therefore we can go here to route and see the plugins that are enabled, and then in this one we will add the file, the name of our proto file. If we save this, right now we should be able to make this request, this web request. And so if we now refresh this page, we should now see the alert for the request and the alert for the response and the alert for the result. So let's try and do that. Yeah, and again, the same issue as we have seen with the gateway plugin. The requests from the web are HTTP. They're not gRPC requests. And so that is also part of the reason why we need to convert these requests to the gRPC protocol. So we, as a recap, we are in the web page. Then we have a client that will send requests via HTTP, which is what we see right over here. This is an HTTP request to our API gateway. And this HTTP request is made within a different gRPC protocol, that is the gRPC web protocol, that then gets translated to gRPC to send the data to the service. And when that happens, then we get a correct response. So when we refresh this, then we see the correct responses. If you have noticed, you have seen the response 0 for user blocked. The reason why this is happening is because I didn't build the code, of course, before I started the container, and I didn't rebuild the container. And so the best thing to do now is just to do just that. And for that, let's just make the build of this project. So the idea is that we create a new jar, and then we put this jar in the new container. And that's why we are also going to run docker compose build. Okay, now we do, but first we do docker compose down. There are better ways to do this, but this is probably the easiest way in terms of command line, because we are still going to have to wait again for Kong to resynchronize with the containers. But yeah, so there has been, this is cached, but we can see that the jar has been copied. So if we do a docker compose up, in this case, so the containers will now start, but the container of the WLSM messenger service will now start with a new jar. And so now we should be able to see that it will return a response 1 instead of 0 for the user blocked. So let's see if that's exactly what will happen. We'll refresh the page. Nothing is happening now because, of course, until the container synchronizes with the Kong Konnect, we will not be able to have the gateway ready to relay our requests to the service. And it has started right now. So if we do this, now we have 0. For user blocked, it should respond with 1. And that's what we get. So the container is clear. So let's recap. So let's recap our configurations. What we have done here in this case was we created a service. Then in this service, we created a route. And for this route, we have created a plugin. And this plugin, we have configured it to be a gRPC web service that uses the protobuffer file messenger Kong proto that we have sent out via the copy commands, the Docker copy commands that I have showed you before. And we have made our routes to be HTTP and our service to be gRPC. And the reason for this is that the routes is what we use to connect to our API gateway, and the service is what we use to be aware of the existence of the services and how do we communicate with them. The plugin the plugin sits in the middle of those two to provide the translation of the incoming request to the outgoing request to the service. And this concludes this the subject of this video, which is essentially and in the end about the gRPC plugins that we can use in Kong. We have seen in this video how the gRPC protocol works, how does it work for clients, for services, and for the gRPC web clients. We have also seen different ways to install these two plugins that Kong Konnect provides. These plugins work basically to convert HTTP or HTTPS requests to gRPC requests. They have different names, and so let's now draw some conclusions about our experience and see how that plays out or how that could play out in future developments where you may want to use these plugins. For both plugins, we see that they use HTTP and HTTP requests. So they make a conversion. For example, if it is a JSON request, it does a translation to a gRPC request, and that is the same for the gRPC web requests. They both make translations to gRPC. They need a protobuf file. So in both cases, we have seen that the Kong gateway, and this is logic that the Kong gateway cannot do that for us, because it needs to know exactly the definition of the protobuf file. We have seen a clear distinction between the protobuf file needed for the REST requests using JSON and the one for the web plugin. For the web plugin, the REST requests aren't needed because the only thing that it needs to know is how the protobuf file is defined, and with that, it already knows how to translate and relay data from the gRPC web request to the gRPC request, which we have also seen that the difference is mainly that one is an HTTP/HTTPS request and the other one is a gRPC/gRPCS request, with translation from one to the other. We need for both plugins to work, we need a service configured with gRPC so that we become aware of our service that is running with gRPC protocol, and a route which is our contact point between our clients outside our internal network through the API gateway using Kong. So Kong Konnect needs to have a service and a route, one with gRPC and the other one with HTTP requests. And for the gateway plugin, we know that it will convert JSON to gRPC. We know for the web plugin that it will convert gRPC web requests, thus HTTP requests, to gRPC. And we know that for a direct gRPC communication, we need that both the service and the route, both of them need to be configured with gRPC, because the first contact point that we do with the API gateway using a direct communication is of course not HTTP, HTTPS request. It is purely a gRPC or a gRPC-S request. All right, everyone, this is the end of our video. The project location is this one, http github.com j-Esperancinha Wildlife Safety Monitor. You can clone it using git clone, but there are different ways to clone projects via GitHub. You can also download the whole project in a zip file. I say here that you can be prompted for a username and password. That's normally what you do if you use HTTPS to check out the project, but you can go through it as you will. And make tests on your own, just not commit or push requests. But I welcome that if you open bugs or issues or things that you want to see in GitHub, or if you just leave a comment in the comment section of this video. The resources that I have used are listed in this list of URLs. These are essentially, in a nutshell, the gRPC.io website where I've taken a lot of information about how to build this project and how to create these examples. You have the original examples in the protocol buffers GitHub repo. You also have different examples in the gRPC web website, where they have a very nice example of a Hello World application. And if you have any questions about this presentation, please make sure to leave them in the comment section below. I welcome all kinds of questions and comments. I also am interested in knowing how this video played out for you and if you found the video interesting. And if you did, don't forget to leave a like. Don't forget to subscribe to don't miss out on other videos that I will also be posting in this channel. And until the next video, have a good one. I have created this video with my knowledge as a Kong champion. I am not affiliated with Kong, and I am not affiliated with any of the brands shown. This video is an educational video to help understand how can an API gateway help when implementing systems with gRPC protocols. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.